Hello, my name is Alex Kluwer. In this video, I'm going to be discussing crosstalk equations, and I'll be discussing how to estimate the amount of crosstalk that is generated by an infinite number of transmission lines. So, I'll be discussing this from a book that I wrote, and in this book, I verified the crosstalk equations that you can find online, and these equations are given here. This is the near-end crosstalk equation, and it states that the near-end crosstalk is equal to 1/8 multiplied by the ratio of the mutual capacitance to the capacitance plus the ratio of the mutual inductance to the inductance. And this assumes that these ratios are much less than 1. Below 1/10 is good. And this just assumes loose coupling. So now the far end crosstalk equation, it has two conditions, like two cases. Case one is when it's saturated, so it'll always be 1/4 maximum far end crosstalk will always be 1/4 if it's saturated. And if it's not saturated, it'll be 1/4 multiplied by the ratio of the propagation time to the rise time, and this is 0 to 100 rise time. And this is multiplied by that same ratio, but instead of being added, they're subtracted. And the condition for saturation is given by this equation. So if the rise time is less than this term here, then it will be saturated. So we can take these equations and we can expand, we can account for an infinite number of lines by first looking at how the mutual inductance and mutual capacitance curves look versus spacing. So you can use ANSYS Q2D, that's what we used in the previous video, to find the curves for resistance and conductance. But if we do the mutual inductance versus spacing, so you have mutual inductance on the y-axis, spacing on the x-axis, and you do this for the mutual capacitance as well, you'll find that these equations here match those curves very well. And you can then plug those into the crosstalk equations. And what you can do is you can assume that all your tracks are going to be equally spaced, so you can discretize your spacing. So you can say that it's a certain amount of space multiplied by an integer. And when you can do that, you can then expand these equations to solve these equations for this equation and this equation here. And if you will find that you can pretty much quadruple the amount of crosstalk, and that will account for an infinite number of lines. It's around 3.7 or so usually. And that's all I wanted to share in this video.